For today, I think I wanted to start with bringing our breakout leaders, or breakout representatives at least, onto the stage to give a few minutes overview of what happened in their breakout. So breakout reps, if you want to come on up on the stage here. And then if we have a few extra minutes, maybe we can get to a little bit of Q&A for any of the presenters earlier that had to squeeze into that 20 minutes and didn't have time for any in their talk. So with that said, let's see, I see one, I see two. Why don't you come on up stage. Do we have our representatives from the other two breakouts here? Abraham, great. And come on up. All right, and let's make sure we get the camera on the whole stage here. Okay, so we'll start with cognitive overload.
Thank you so much. My name is Jeanne. Our discussion focuses on enhancing virtual reality experience and design multimedia performance art to minimize cognitive overload. Key themes included the necessity of customization to accommodate individual preferences, reduce sensory strain. Some strategies proposed included simplifying visuals, using non-invasive alert and haptic feedback. Group discussions highlighted the importance of sensory cues in defining spatial boundaries and enhancing depth perception. Innovative suggestions such as using AI to automatically adjust user settings and offering various locomotion options were also discussed to cater to diverse user needs. Thank you.
Awesome, thank you. Yeah. All right, next up for sign language, we have Abraham.
Great. So sign language technology is still in the infancy stage. So we had an open discussion that was quite creative, and we identified some challenges, which are lack of data for training AI in different technologies for sign language. We don't have enough data sets quite yet. Secondly, there are a lot of companies and groups that tend to have a goal for complete sign language recognition and jumping way ahead, and we can't get there. We have to focus on smaller, useful steps forward to get to that point, incremental steps or baby steps. And next, we discussed 2D technology versus 3D technology. And for sign language, we still don't have a lot of working technology for 2D yet. So can we apply what we've learned to 3D, or maybe we need to start researching 3D in parallel with 2D and see who wins and who gets there first, whether it's 2D or 3D. And one thing that we noticed with current technology is that AI is not good with hands or hand shapes. And so maybe you've seen some images created from AI, and they really can't make good hands quite yet. So we discussed that, and that has its own challenges for sign language, of course. And finally, we also discussed two ways of interacting in sign language versus, what I mean is receiving information versus communication in XR. And so really there's a lot of open challenges that are ongoing, and that's what we discussed.
All right, thanks very much. All right, next up, we'll pass the mic down to Peirce and Jeanne.
All right, hi everyone. So we were talking about immersive healthcare. We tried to talk about all the use cases in healthcare for VR, which there are plenty of, and we tried to figure out how accessibility in healthcare can overlap so that everybody can benefit from healthcare using immersive tech. Some of the use cases we talked about are exposure therapy, including PTSD, some phobias, substance abuse disorders, and mental health. We talked about use cases in radiology, including in medical imaging and diagnostics, especially the ability to identify tumors using AR projections. We talked about VR assistance in surgery, and some of the considerations to include in that. We talked about training and healthcare practices using VR simulations, including medical education and patient education too. And so for some of the challenges, I'll pass it to Jeanne.
Hi, my name is Jeanne. So here are some challenges. The first is the trust in technology by patients, especially for elderly patients. They are the main users. And the second would be the ROI needs to be demonstrated by hospital systems or insurance. And also VR treatments are not personalized yet. So there are some parameters such as age group, health condition, and severity need to be considered when designing for healthcare products. And also new technology can be intimidating to people, especially there are some technological literacy issues within elderly adults patients, as we just mentioned. And also the processing challenges in real time, especially when there's a VR surgery and the Wi-Fi issues or all kinds of technical issues would be really challenging. And finally, there's the dissemination of practices for different types of disabilities. Thank you.
Awesome. Thanks very much. And then finally, for the productizing, creating scalable solutions, we have it's Veronica, right?
Yeah.
Yes.
Hi.
Volunteer.
I'm Veronica. So in my group, we discussed a few things. So first of all, strategies to prioritize accessibility in a company setting when it may not be profitable to do so, but it's the right thing to do. So what are some different ways that we can prioritize accessibility? Making your research innovations or tools into actual products. So we talked about entrepreneurship. And a way to do that is by using your school's resources to make a switch from academia into industry. And then the main takeaway that I found from this talk is that accessible tools or features often benefit users who also do not have disabilities as well. And so in general, accessibility is good for everyone. And a lot of companies will have like retention of their employees if they have accessibility. So in the end, it is more profitable and it's not just the right thing to do. So, thank you.
Absolutely. Thanks so much. All right. Thank you to all of our breakout leaders here. You can go ahead and take a seat. I hope you all enjoyed the breakout sessions. I know for me, I find them as really one of the most valuable parts of the conference because there's so much that we don't know and that we haven't collectively figured out. So much stuff that isn't just we're going to tell you the answers and let's come up with the answers together. And I really value our breakout sessions as a place to do that. So we'll have 4 more tomorrow. You should be able to find them on the symposium website now. I know they weren't showing up earlier today. But with that said, I think we have just a few extra minutes before our outro here. So I wanted to take the opportunity to first ask up any of our speakers who are still here, who haven't had to leave early, to feel free to come up and have the opportunity to answer some questions that there may not have been time for earlier. And then second, I'd love to just hear from you all. What were your favorite parts of today? What lessons have you learned? What things are you taking with you? And what do you want to talk about more and learn about more tomorrow? So first, I think we have Jasmine over here at least as a speaker. Come on up. Any other speakers are welcome to come up as well if you like. Come on. At least a couple somewhere. Maybe there's China. Okay, we got China. All right. Is that? Oh, sorry. God, I'm getting people mixed up.
No, you're good.
Oh, okay. All right. So let's see. Why don't we go ahead and Jonathan, if you want to roll us back to maybe Jasmine's slide first, so we can remind everybody what these are about. Oh, there you go. Just pass it. No, it's
XR
after the story stuff. Yeah. There we are.
Yes. Thank you. All right. So it was probably
never mind, it has been a while since I gave this talk this morning. So quick summary, I'll try to do a recap of what I talked about. Essentially, me and my lab mate here, Ricky, talked about a project that we did, which was a diary study where we investigated the daily use cases of computer vision applications in the lives of blind and low vision people. We listed for you guys some of the interesting findings that we found, like the fact that accuracy wasn't always the most important thing when it came to how good these descriptions were, but rather the user's own knowledge and what they were able to figure out was a lot more important to them. We also talked about some of the top use cases we found from those diary studies, things like identifying specific subjects, using AI to win arguments with your friends, good fun stuff like that. So yeah, it was basically just this nice diary study that we did about computer vision application use cases. And that's it in a nutshell. Oh, we also talked about our future XR work, like our current AI guide project that some of you checked out in the demo. So I suppose I could also answer questions about that demo if you guys have questions about that and you tried it earlier. But yeah, that's my nutshell. And any questions?
We got one over here.
Yeah, hello. And so in your talk, you talk about like sometimes accuracy doesn't matter, but like in the example you show, there is a sense of accuracy in the description it gives, which I say it's a really important accuracy is that it states like a white device, right? And here, like, although if we look at the sentence as a whole, and if we focus on the like what's being described is wrong because it's not a device, it's a paper. But by giving the description that it's a white device, it's also like a very important cue, and which is a very important and accurate cue for the user. So have you ever thought about like trying to evaluate the accuracy of the description from a different perspective, where like it's like different from how we read it, say like we evaluate whether the objective is right, but do you try to evaluate the accuracy in terms of whether it gives a accurate description of the characteristics of the scene, say it's being white, say it's a wood or whatever?
Yes, actually, a great question. And so that's actually something that we talk about in more detail in the paper itself. So for our idea of accuracy and the way that researchers scored accuracy, we had a score out of 3 points for each application description. And overall, what we defined as accuracy for doing that was, does this match basically a human sense or a human evaluation of the image? So that's kind of where this phrase of being like, oh, there are some accurate details in here, but overall, it doesn't really match like a cited interpretation of this image. That's why it's kind of inaccurate. But the actual point system that we had for how we were scoring the application descriptions was each of those 3 points matched to a different factor of what we considered to be an important aspect of accuracy. So that description, for example, got 1 point, which was for the factor of basically like correct details, more or less, which was things like color, if it got a color correct or if it identified a particular object correctly. But a different factor of accuracy would be things like how much coverage was there of the photo. So for example, how many of the objects that were actually present in the photo were present in the description. So those different 3 points that we had each kind of represented a different vector of accuracy, since there's no really kind of optimized way of defining accuracy. So we tried to represent it as closely as possible. But yes, so to answer your question, that is something that we thought about. It's not something that can always be present when we try to boil it down to a number, but it is something that we discuss and talk about in the paper and that we tried to implement or operationalize at least a little bit when we were judging the accuracy of these descriptions.
Awesome. And then, Jasmine, I had a question about that actually. Been thinking a lot about form factors lately and the form factor of a smartphone versus the smart glasses. I had the chance to try out the Meta Ray-Bans earlier, where it's got AI built in. You just tap it and it tells you about what you're looking at. I'm curious if either in your study or in the other studies you've read about, there's a lot, like what are the key differences between AI utilized via a smartphone camera and AI utilized via a wearable?
Ooh, that is a very interesting question. So for our study, we did not look at form factor at all. We were mostly just focusing on mobile computer vision applications, like Seeing AI. Basically, we were trying to mimic what is most commonly seen in the commercial standard, which is you pull out your phone, you take a picture, and you wait for this app to give you a response. So we didn't really explore with any of these other types of form factors. Although in our interviews, we did end up discussing some of these with participants. It's not a point that came up in our paper because it didn't didn't come up a lot. But I do recall one of the participants who talked about trying to use an app like this on a smartwatch, like a wearable, not like a glasses wearable, but a smartwatch wearable. And they talked about how they would like to be able to, for example, like make subtle gestures or subtle motions on their wrist and kind of take pictures. And instead of like having to hold up the phone and like basically broadcast to the world that they're taking a photo, if they could interact with like a piece of their body, or I guess the glasses, they like the idea of that subtlety. The challenge that came up when they tried beta apps for that, because they mentioned a beta app that they tried, was obviously just framing, basically. So getting it to actually point at what they were trying to take a picture of. So with a wearable, it's like how you can't really like look at the camera and adjust it. You can't really see if it's capturing things correctly. I don't know how that project or that problem would come across in a glasses wearable, because you might have a much better idea of what it's taking a picture of, since you're actually looking ideally at the same thing that it's taking a picture of. But yeah, that was kind of like a minor point that some of our participants brought up, but definitely not something that we considered really strongly in this study, but something that we could consider going forward, especially with the Meta Ray-Bans and these new kinds of wearables that are becoming much more popular.
Awesome, thank you.
Yeah, hello. It's not my research, but from my previous experience, I can share a little bit about wearable devices compared to the mobile devices. So mobile is already a developed architecture, has already a developed architecture, and most of the things are optimized. But for the immersive technologies like VR or the glasses, they are still developing. So for example, for the glasses, there is a computational limitation, like how much time it can continue recognizing something or taking picture, because it has a battery limitation. So if you can always put more battery or something, then it will after that it will be less usable. So we need more compact device, but more powerful. But good thing is that wearable devices such as Ray-Ban, Meta, they use the API. That's why the computation and everything happens behind the cloud. They just use send request and receive that one and display the information. So things are getting better nowadays. So hope everything will be different after 5 years from now.
Gotcha. Yeah, things are definitely changing fast. Awesome. Any other questions from the audience? Yes. Here, let's get a microphone here.
I'm wondering about the recruitment criteria you had for participants, like if you had any. So for example, like did you have users who had previous AI experience using like this app, or were they completely new to it? Like, did you log that?
We did log that. Yeah, an excellent question, as Shiri just said in the front. For our for our recruitment criteria, we really only required for the participants that they have be like blind or low vision. We didn't require like a specific measure of visual impairment or anything like that. They just had to identify as like blind or low vision. We asked them some initial questions in the screening about their vision. And in that initial screening as well, we also asked if they had prior experience with things like AI apps. We asked if they had experience with also just visual interpretation apps in general. So even the human powered ones like BizWiz or Ira. We even also asked a little bit about informal visual interpretation, like asking about like video calling with a friend, for example, or a family member, and using that as a form of visual interpretation. And it wasn't a requirement that they had that prior experience, but all of our participants did have that prior experience. It's very, very common. I think, in fact, all of them did have experience with AI apps, some more than others, of course. Some had been involved to the point where they were beta testers or had been like actually on development teams. Others just used it in their daily lives, or others who especially had just gotten their impairment were more new to using these tools, but everyone did end up with that experience. Wasn't a requirement, though, just sort of happened.
Awesome. And then I want to give some time here. And sorry, remind me the proper pronunciation of your name, because I think I was. Right, Shahinur. Okay, fantastic. Yeah, let's switch it over to.
I was just kidding.
Yeah. And yeah, if you want to just give a very quick recap, and then we'll give folks a chance to ask some questions.
Yeah, sure. It's a great opportunity that I'm getting extra time to explain my work again. So we have developed a game named ASL Champ. So the main goal of this game is to teach American Sign Language to the hearing individual. So compared to other method, like if you want to learn some sign, maybe you can go to YouTube, or you can go find some website online. They have lots of like video or animation, but the thing is that for example, you learn something, but you don't know you are doing it correctly or not, because sign language is kind of complex, and even a single movement or can change represent a different word or something. So we have developed a feedback system that can provide feedback whether you are signing it correctly or not. So we have developed, we have considered two things. One, we wanted to develop something that where user can feel like they are really immersed in a classroom environment, and also they can get feedback whether they are learning it correctly or not. So we had a demo session. Some of you already have tried, and I got a bunch of questions. Yeah, I have answered most of them, but yeah, this is a great time to take more questions now.
Yeah, I know I had a question when it comes to, we've talked about avatars and ones that are, aggressively A-posing or otherwise. I've heard for sign language that the kind of emotional expression, and it's not just about the hands, right? It's about the interplay of hands and face and kind of your whole upper body. I'm curious how that comes across, or if you found that to be true, and if so, how did it affect the design of your kind of avatars and whatnot, or what were the limitations you had to work with there?
Yeah, that's a good question. So sign language always comes with different facial expression. For example, we say like yes or no questions or WH questions. So in sign language, for example, if I say, have you taken your lunch? So even though I do not questions, but if I just use my eyebrows, I can ask a question. So that's an important thing in sign language other than normal language like English. So in that case, facial expression is really important. So now we are working on Oculus Quest 2 and Oculus Quest 3. It has no option to get the facial expression. But recently we have got the Pro, Quest 3 Pro, or Apple Vision Pro, or Microsoft HoloLens. These have some kind of option to track the facial expression and everything. So we are planning to ship from Oculus Quest 2 through Quest 2 to Quest 3 Pro, where we can get more flexibility to work on the facial expression. And also there are some limitation on VR, like although it can capture the 360 degree, but we cannot go to the up to our head. So in that case, if some sign involved behind my head or something, so we cannot recognize that one. So in that case, we also have to think about it.
Gotcha, that's great. Yeah, I know. I've heard with VR chat, there's a big signing community on there, but signing in VR is kind of somebody said it was like talking with your mouth full to a certain extent. You can't quite. It's like signing in mittens, right? You can't get a lot of the nuance. So definitely, we'll have to catch up more about that. I saw another question over here.
Thank you. I was curious about the signs that had very low accuracy in your test. I can't remember which words it was, but was it because they're difficult signs to make, or was it because they were difficult signs for hand tracking to achieve in VR?
Could you please remind me which sign it was?
I can't remember. It was,
Okay.
if you've got your slides, it was on the chart.
Okay.
Cup, we think.
Cup. Oh, okay. Yeah, this is because of the hand orientation. Sometimes there are some similar sign where our deep learning model can confused. So the only one way we can improve from this is invite more people, gather more data, and train our model.
But you think because of the actual subtlety of the sign?
Yeah.
Can I see the signer say cup?
This is the sign.
Yeah.
Mm.
Interesting. Thank you.
Yeah.
All right, I think we may have time for one more question. Going once, going twice. All right, I think with that, then we'll go ahead and say thank you to our speakers.
Yeah, thank you. Thank you, everyone.
Glad we had this opportunity.